Guys, we're going to do some work here on exponential functions and specifically writing exponential functions from a table. So in our classes this year already, we've done exponential functions a little bit. We really did them in the form of geometric sequences. So we're going to look at these a little bit differently than we did those, but it's quite similar. So exponential functions are of the form y equals, my pen working better, y equals a times b to the x. And we could also see it f of x equals a times b to the x. We'll probably stick with the y equals because when we get into our problems on delta math, I think they have them with the y in there. They really mean the same thing, but f of x tells us it's really a function. It's the value of y when the x is whatever we plug in for the x. So y equals a times b to the x, where a is the initial value. That's our initial value. That's really the y value when x equals 0. So similar to like our y-intercept, well, it is the y-intercept, but it's the same idea when we did y-intercept with linear functions, right? It's a place we know we can start our graph or where our function begins. And b is the multiplier. So instead of going in a linear fashion, these are going to be our curves, right? Our exponential functions are curves, and they're going to multiply and grow fast. If we were together, we'd probably be doing a big workup on this coronavirus, right? Because it's really an exponential situation where one person can get several people sick, and then those people can get several people sick, and it grows really fast by multiplication. So this is what we have here, our initial value and our multiplier. And the x, that's how many times you're going to multiply, right? So that's if we want to know, how many people are going to get coronavirus in 5 days. We start with the initial number of people, how many people they're each going to get sick every day, and then 5 days would be the x. So that's kind of our general form and what those things mean. What you're going to be charged with doing in our homework assignments on Delta Math is that you're going to need to write exponential functions from a table. So we're going to just look at a few quick examples here, and we'll get you started. So first table here, really label them, we'll call it A. We're going to look and see if we can find the initial value, right? So remember our initial value, we said that's the y value. See right there on top when the x is 0. So this is my initial value, right? That's my A. Then we need to look and see what our multiplier is. So we really should check and make sure they're multiplying the same every time. So from 1 to 3, that multiplies by 3. From 3 to 9, that multiplies by 3. 9 to 27 multiplies by 3. 27 to 81, that would multiply by 3. So that means my b is 3. So now I know the two things that I need to make an exponential function equation. So I can write my equation y equals, I'll just write the kind of formula here, b to the x for the first one. So y equals a, which is 1, times b to the x power. And if the a is 1, really you could simplify it and lose the 1, but I'm going to leave it there for now so you can see where it came from or where it goes. Okay, so we're going to do 3 more of these, and that should get us off and running. So same thing here. All of our tables actually start with 0. It's possible we have other entries, and maybe the x entry into our table isn't going to be right on top. So you want to make sure you look for where the x is 0 and see what the y is, right? So this tells me the a is 2. My initial value is 2. And then I'm multiplying from 2 to 8 by 4. Right? And I really should check and make sure they're all the same. 8 times 4 is 32. 32 times 4, double it is 64. Double it again is 128. Yep. double it and double it is 512. So that tells me that the b is 4. So my function for this table here, I know that y equals a, which is 2, times b, which is 4, to the x power. Okay, we got 2 more and then we are finished. So those were pretty straightforward. These here are also pretty straightforward, but they're a little bit different. You can see this one we'll call C. This one has decimals, right? So sometimes that makes it seem like it's harder, but it's really the same thing. We're going to find where the x is 0 right here, and I'm going to look and see what's my y, right? So the a value, the initial value is 0.5. And then I'm going to look and see how it's changing by multiplication. So from 0.5 to 0.25. Uh-oh, we have a problem, right? I know a lot of students are going to look at this and tell me that the multiplier is 2, right? But the problem is it's not multiplying, it's dividing, right? But we need to put our b term as what we're multiplying by. So I'm actually, if I'm cutting it in half, right, from 0.5, like 50 cents to 0.25, from 50% to 25% is getting cut in half. So that means it's multiplying by a half, right, or dividing by 2. So same here, it's multiplying by a half, and a half, and a half. So there are some problems on Delta Math, that's why I picked this, where it starts with a decimal and then it's getting smaller. So one thing we didn't really talk about, which we should, if it's getting smaller as the y goes down the table, as x gets larger, if the y gets smaller, that means the b is going to be less than 1. And we're going to talk about this a little bit more in the next video, but for right now we're just looking to see how does it change. So b is going down, it's going down by a half, so the b is a half. So my equation for this one, y equals a, which is 0.5. I'm going to use parentheses here so we don't get too confused with all these dots, times b, which is a half. So I could write that as a half, or I could write that as 0.5. It doesn't matter, I'll just do it as a half here, to the x power. And our fourth and final one here, we'll label it D. We're going to do the same thing. Look for where the x is, 0, and I'm going to identify this as my starting point. So my initial value, my initial y, is -1. All right, that's a little bit different. These are all negatives, so looks a little bit more challenging maybe, but it's really the same exact thing. A is 1. As we go down from -1 to -4, that multiplies by 4. From -4 to -16, that multiplies by 4. From -16 to -16 multiplies by 4. Right? Every single time it's multiplying by 4. So my a is -1 and my b is 4. So I can write my equation just like I did before. Y equals -1 times 4 to the x. So those are pretty straightforward. Again, don't be intimidated if it has a fraction or a decimal or a negative number. You're going to follow the same process every time. Find the initial value and then find what it's multiplying by. One quick note, if you're not sure what it's multiplying by, right, like maybe this one over here in part C, you're not sure what it's multiplying by, right? The trick that I used with my class was, well, we used to, when we wrote the tables kind of sideways, we'd say right over left, right over left. You're going to do 0.25 divided by 0.5. And if you divide those out, you'll get 1/2. So you can, if it's getting, you just recognize that if it's going down, you're going to have a fraction or a decimal less than 1. Okay, that's all we got for this lesson. This should get you set up for your Delta Math problems pretty good.